Hello, this is Marfasak speaking, and this is my second video about this Internet of Things prototype. What this prototype does is it reads the temperature of these sensors over a Bluetooth communication using this Android Things hardware. Then the readings are displayed in these two displays. I'm using two sensors because the third one broke down, so it displays the readings in these two sensors, and then from here we are uploading the readings to the cloud using the MQTT protocol, and from there we are sending the data down to the client. So this is the status of today of this project. I'm just going to summarize the different technologies that I have used and the advantages and disadvantages of them. So basically, as I said, using Bluetooth low energy communication, the Android Things application running on this hardware is connecting to each of the devices in order to make the reading. We can see this in this LED. When the LED is turned on, it's connected to each one of the sensors. It's making the reading, and then the reading is going up to the cloud using the MQTT protocol. This is a protocol with very small footprint, meaning that it uses a very few amount of data, and then from the cloud we are sending these results down to the client. The way we are doing this is we are using the latest infrastructure, the latest products from Google. We are using Firebase Cloud Functions, meaning that we don't need to have a backend. We don't need to spin up an App Engine instance or different App Engine instances. Cloud Functions is doing this for us. It's like, from my point of view, without going into the details, but it's like a very simplified App Engine that we have running in the cloud and that we program using JavaScript. We deploy also up to the server, so it's similar. And we are using these cloud functions to resend the MQTT messages that we are sending from this hardware. We are sending them down to the client. In order to do this, we are using the PubSub real-time messaging system from Google. This Android client is subscribed to a topic where this hardware is publishing the results. So the way we do this is, in the market, in real life, there will be one client which will be linked to a hardware, and this link is what we use to take advantage of the topics feature of the PubSub messaging system in order to publish the sensors to these topics and to read them from this client. Next, another thing that we can see here is that we are sending the messages down using Firebase Cloud Messaging. This is done because Firebase Cloud Messaging is free, so it has no cost for us. Still, it's not very fast. As we can see here in this Android client, and now it's 13:01, but the last temperature reading that we have received is from almost 4 minutes ago. For the purpose of this application, these 4 minutes are not a big problem. It's not critical if we know the temperature 4 minutes before or 4 minutes after. It could be a little bit annoying if the user is watching the readings on the display and on the Android client and seeing that the results are not the same. Anyway, this is going to be improved, adding Firebase real-time database in future videos. But for the time being, this has been a very good solution, a very cheap solution anyway. Cheap because it has no cost for us to send the data to the client. Also cheap because we are using the MQTT protocol, using very little data. And also this solution is ready to be deployed in a rural area, for example, where there is no wireless communication. We are here connected over the LAN. We could be connected over Wi-Fi, but we could also be connected using a telecommunications SIM card. So using this protocol, as I said, is like the one that is cheaper in terms of data, and this is the one that we have used. So I hope you find this interesting. It's a lot of software and hardware involved framework, but very good solution to monitor the sensors, 3 sensors in a house remotely. In next videos, we will see how we can switch on the heating and different things that we can do with this infrastructure, with this software solution, and with this hardware. Thank you.